Me.
はい。
YouTube started now.
Move on. Okay.
Okay.
All right. Let's get started. Hello everyone. First of all, thank you so much for joining today. I'm really happy to spend this time together with all of you. And to our speakers, thank you. We totally appreciate your time and the story you are going to share with us. Today we have a wonderful lineup of speakers, each bringing their own unique experiences and perspectives. I'm really looking forward to hearing what insights and stories they will share. So, even if it's just one moment, one idea, I hope today's sessions spark inspiration, new connections, or curiosity for you. And also, please feel free to post your thoughts, share your social links, or just say hello to each other in the chat. It's a special global event, so let's make it lively. Okay. So, I started this community to bring together people who care not just about AWS, but about each other. So now I co-organize it with Yuki, and we are always happy to welcome new helping hands. If you'd like to get involved, just reach out. Let's build this community together. So today's schedule. Now let me quickly introduce this schedule. We have another amazing lineup of speakers. Today we'll hear from Matthias, Adbulavin, Nayam, Jones, and Thelma. Let's give them a warm welcome. I'm so happy to have you all here as part of this global community. And to our speakers, thank you so much for your time and for sharing your valuable stories with us. We follow the order shown on the slides, so please take a look if you'd like. The event will last about 2 hours, and we'd love for you to stay with us as much as you can until the end. So, let me share a quick note about this meetup. We are streaming not only on Zoom, but also on YouTube. If you are joining Zoom, please feel free to drop your questions or comments in the chat anytime during the sessions. And if you like, at the end, we'll be so happy to hear your voice too. Just you need unmute and share a quick thoughts, even just one word. Together, let's keep growing this wonderful global community and continue building strong connections with each other. So, how many of you are joining us for the very first time today? For those who have joined before, you may already know this. But let me briefly introduce our community. This community started with the hope of creating an inclusive and welcoming space where we can all run together uh, by connecting people around the world source AWS and the technology. We want the stories and the ideas shared here to inspire you, uh, even in small words, and help you take your next step forward. We especially welcome these who are speaking for the very first time, or who haven't had many chances to share their own stories before. I truly hope you all find this to be a community where you can feel safe to learn, connected, and grow together. We also have a Discord, so feel free to use the space to keep the conversation going. You are welcome to join and use it anytime after the meetup. So, we host events every month, and we are always thinking about how to take this community even better. We'd love for you to keep joining us. And if you'd like, you are more than welcome to step up as a speaker too. We are always excited to hear new voices and fresh perspectives. So if you are even a little bit interested, please feel free to reach out to anytime. Right now, we are especially welcoming speakers for November and December. And if you are ever so, maybe I could give it a try. This is your chance. We'd love to hear your story, and we can't wait to see you on stage. And don't be shy. We are here to cheer you all. And so, let's keep building this community together. And now, I have important announcement to share. The Awesome Women 24-hour event will be happening online, and it will be led by our LATAM members and will connect the people globally. Don't miss it. All right. Let's get started with the main session. Thank you. Okay. Matthias, I'm
Hi,
ready.
how are you? How
I'm
are
good.
you? Thank you for inviting me.
Thank you so much.
So I'm gonna share my screen.
Yes, good.
So okay, let me know if you can see it.
Perfect.
All right, thank you so much. Um, okay, so today I'm in a special place. I'm in a technology conference. AWS has a booth. It's in my bag. I might show a little bit about it, but the general idea is like this is a technology conference that is happening here in Argentina. There is around 10,000 attendees, and I had the opportunity to give this same talk in the technology in the AWS booth yesterday, and today I wanted to show it to you so that you can see what I have been doing, what I'm working on, especially around AI. What we are going to talk about is different ways to use AI on AWS, and hopefully at the end of this call, you will be able to see a QR that will point you to a blog that I wrote, and it has some examples and code snippets and everything there, so you can see more on that. So let's get started. First of all, I want to introduce myself. My name is Matias. I'm from Buenos Aires, Argentina. I'm the CTO of Mechanized AI. We are an AI startup. I'm also a professor on a university here in Buenos Aires, but I also collaborate with AWS in multiple programs, including the AWS Community Builder program, the user group leaders. I'm part of the certification SME program as well. I collaborate on the creation of two certifications with AWS, especially around reviewing the content, creating exam items, questions, and so on. So yeah, that's me. I have also been a lead racer finalist for 3 times. So I had the chance to fly to reinvent and compete with people from all over the world. So yeah, that's pretty much that's me. So let me let's jump in and talk a little bit about well, this talk. The main idea is that I build a system for HR. The idea is that people, screening candidates, they can use AI to review candidate resumes in some way. The main goal is to try to, investigate if the candidate is a good fit for the role or not. In particular, the AI will generate certain things like it will generate like an output of gaps that it sees on the candidate, that maybe some skill that they need to fill. It will rate the candidate as well, and it will generate questions for the interviewer. So I built this in 3 different ways. The first way was using step functions and Lambda. This, of course, is not an agent, but it's a good example of technologies that you can use on AWS to orchestrate different LLM steps. On this architecture, we are using Lambda and to call Bedrock for each one of those steps. And then a step function is the orchestrator that's going to be calling each one of them. And like I said at the beginning, after the demo, I'm going to share a link where you can review the entire thing. It has a GitHub repo as well where you can deploy this by yourself. But the general idea of this architecture is that you can grab the resume from S3. That actually triggers like event bridge rules that will start the state machine, the state function, generate all the outputs, and then the outputs are stored in DynamoDB in a structured way, which then you can connect into any tool that you may be using, such as your own UI or anything. So so that was the first one. The second one is using Bedrock agents. You are probably familiar with this, but a Bedrock agents is a technology that has been in the AWS ecosystem for some time. On this example, I'm showing there is a restaurant agent that has 2 different functions. One of them is to generate like reservations. The other one is to use the menu. As you can see, each one of those have different integrations with Lambda, OpenSearch, and so on. I have used Bedrock agents as well for this specific use case. So basically, the architecture looks like this. It's kind of similar to what we have seen before, but on this case, there is a multi-agent architecture where there is a supervisor agent that it looks into each of the splits the work into each of the agents. Each agent is specialized in one of the tasks. For example, there is one agent that's going to generate like interview questions for the interviewer. There is another one that may rate the candidate and so on. So the supervisor is the one that is going to be coordinating between all these activities. So that is the second architecture. It works exactly the same way. Data is read from S3. processed by Bedrock agent and stored into DynamoDB. So I have been playing with this, and I guess the good thing about Bedrock agent is that you can create everything on the console, on the AWS console itself. The challenges I had was about debugging. Sometimes it was a little hard for me to maybe I was getting error from Bedrock and it wasn't unclear on where it's going from. But there is something called tracing that you can enable on Bedrock that's going to show you like each step that the Bedrock agent takes. That way you can see okay what the error is. And another problem that it might have that it only works with Bedrock, whereas the previous methods with step functions. Of course, if you want to use something else, AI from some other place, you can just change like the Lambda code. But in this case, if you choose to use Bedrock agents, you are going to be using all the elements that are available in Bedrock, which are a ton, but you're going to be limited to that. So keep that in mind. And I guess the new thing, everyone is talking about strands now. It's a very powerful tool, to be honest. For those that don't know what it is a library that lets you create your own agents. You can create like a simple code and define everything okay, this is agent A, this is using, certain tools. For example, to connect into a Lambda to a Lambda to do something like using an API call, like in the restaurant example that we have seen, maybe we can use an API call to make a reservation, for example, or anything like that. So you can do the same things with strands. I guess the difference is that it's gonna be more on the code side. You can code all the agents entirely. But the good thing with the strands is that you can run it anywhere pretty much. You can run the agent locally to test, but you can also deploy it into ECS, or you can deploy it into Lambda or any other place that you might choose, or even the new Bedrock Agent Core, which is what I'm going to talk about next. So there is this new product called Bedrock Agent Rock that lets you deploy the agent into this service. It works with the strands pretty well, but it also works with any other agent technology that you might be using, like LangChain or any other thing. The good thing about Bedrock Agent Core is that also has some other tools, like for example, it has a built-in browser extension where you can use like a browser for certain tasks, or there is like a code isolation extension as well, where you can create your own code and then test it in a sandbox in a secure way. So this is how the same structure will look like with Bedrock Agent Core. Again, we have like a supervisor agent and different agents that are going to be tools under that supervisor. It's working really well. For me, I have deployed this into the strands into Bedrock Agent Core, and so far I think it's a good solution. I guess some challenges I have is the deployment itself is a little challenging for now, because there is a CLI tool that you can use to deploy everything, which is called Agent Core CLI, if I'm not mistaken. But then once you deploy, there is I mean, it's working okay, but what I should say is like there is no CloudFormation or other EIC tool like Terraform doesn't even support this tool, so there is no way to productivize Agent Core yet. But you have to keep in mind that Agent Core is in a technical preview stage, so I'm guessing AWS is gonna release it soon. So yeah. So some of the difference that I have seen on the execution times, for example, the step function, like I said before, is not an agent, it's just a workflow on how you schedule and orchestrate things. Whereas Bedrock agents and Bedrock Agent Core usually take a little more time, because that is the time the supervisor agent talks with each of the different agents and try to agree on what the message is if it got the right response. If not, it's going to ask each agent back and so on. And all that work usually takes some time. So, regarding portability, step functions, you can, use whatever LLM you want. Bedrockation is kind of limited to um, Bedrock, of course, but then on Strands as well, you can use any LLM available in the market. Uh, some architectures are a little bit more complex than others. I have listed some models here, so I have used and that you're gonna see on the blog post that I created. And then on the debugging side, I would say that there are some things that are more easier to debug than others. If a step functions fail, you are gonna see like which step failed specifically, and you can see CloudWatch to see the logs on what's going on. Whereas Bedrock Agent is a little bit more complicated, and I think Agent Core is doing well on that sense. I think things are a little more smooth in that sense. So in general, that is what I found out, during my own testing. Keep in mind, Agent Core is still on technical preview, so I wouldn't use it for like production usage just yet, but it's a good time to start experimenting with it. I think it's very powerful. Keep in mind about the step functions. I think, that is something that people try to avoid because it's not actually an agent, but I think it's relevant for most use cases when you are trying to orchestrate multiple LLMs to do something. Bedrock agents, it's valid, it's production ready, but it's a little hard sometimes. But I think if I were you, I would probably start working more on the Asian core side. I think that is where the future is for sure. And then finally, the Strand agent, like I said, it can run anywhere, so it's a really good tool as well. You can run it locally on ECS or any other place. And I think that's pretty much it. If you want to read about this, you can learn more from the website. If you click, you cannot click, of course, because it's a presentation, but if you scan the QR code, you are going to see that the entire article that I wrote that explains all of these things that I talked about, and it has like complete examples, the full comparison, as well as some the GitHub. On GitHub you're gonna see the code for the entire solution itself. So yeah, that's pretty much it. I don't know if anyone has any questions on the Zoom chats.
Thank you.
I cannot. Okay, so yeah, thank you so much for having me. If you want to connect with me, that is the QR code that you can use. Yes, thank you once again for inviting me. It's a pleasure for me to be here. Yeah, thank you. I'm really happy for the opportunity. Yeah, I will stay here in the conference, I guess, all day with a bunch of other AWS community fellows and some other people. This is a open technology conference about science, so some of the people attending here are not because of the AWS, but it's gonna be cool. So thank you once again for inviting me.
Thank you so much. Thank you, Matthias, for sharing such a hot topics. The regional review part was really interesting. I even felt like trying it myself. I've also experienced the airport error before. I'm not sure if it was the same issue, but it always felt like mystery. uh,
Yeah.
no, yeah, I'm especially excited about the potential of Bedrock Agent Core. I'd love to learn more and hopefully use it to production workload in the future. All right, that's all from me. Now, uh, once again, does anyone have any comments, questions, or thoughts for Matthias?
All right. I guess that's a now.
Thank you. Thank you.
Okay. Bye bye.
Bye. Thank you.
Bye. Thank you.
All right, then, let's can welcome our next speaker, uh, Abdullah. Are you ready?
Yeah, yes, I'm ready. So just let me know if you can see my screen.
Yep.
Okay. Welcome everyone. Am I audible? I just need your reactions to, so see that my voice is clear to you. I just need some reactions. Perfect, perfect, perfect. So, okay. So, my name is Abdullah bin Aftab, and I'm from Pakistan. I'm a cloud data engineer, and I've been a three certification from AWS, and one is from Azure. So, with all of my certifications, you get the idea that I'm a cloud enthusiast. Also, if I'm talking about my community, so I'm an AWS Cloud Club regional captain of Pakistan. For those of you know what is cloud clubs, so basically cloud clubs are the student community, student elite community, I must say, because they choose only 7% students around the world who can open the club in the university, and they can host workshops, technical session, and just spread the knowledge of the cloud around the campus, right? So this is my work at a community by AWS, and this is my LinkedIn, so you can stalk me there. Okay, so what are the expectations, right? Okay, so what are the expectations of this talk? So I'm going to discuss about my journey, like how I introduced to the cloud, because I'm still a student. I'm in the third, I'm the starting of my third year now, and also I've been working as a data engineer. It's been like 2+ years of experience I have. I'm working with different companies, some contractual role. So this is all I'm going to talk about. Okay, so I don't have that technical architectures in my talk. So I would suggest just go to my LinkedIn. I write some blogs. There are some architectures of the data pipeline here, so you can get there. Okay. Okay. So why AWS? A lot of people, has think about it like why we should use AWS if we are talking about the cloud, AI, data sites, right? Nowadays, there are a lot of clouds. We have Cloudera, we have Azure, we have Google Cloud, and we have AWS. A lot of people have say why we should use AWS, right? So the AWS, the one motivation for me about the AWS is AWS has a great market share, right? Because it's a first great market share. Everyone knows about the AWS, and it has a great community help, right? So, and a catalyst of growth, if this cloud has a great market share, then your learning would be much improved. And also there's a lot of chance to work in the AWS, because the community of AWS is so strong. They are just frequently launching new things, and there's an opportunity to learn, right? And the innovation and impact, if I'm see around the world, AWS just create impact for the students, for the community builders, right? So a lot of application that we have seen, a lot of government projects, it's done by the AWS, right? So I love AWS. Okay, so let's move forward. So let's slightly talk about the data on AWS, right? So basically, people had say whenever I'm talking about the data, so there's the first thing that comes in the mind, which is SQL, right? So people must thought that, hey, you are data engineer, so why you need a cloud for it, right? Why you need a cloud for it? The data should be on your own computer, on servers. You just have to write some SQL, some transformation, and you can just send the data to anyone else. No, nowadays data is a big thing. Data is the oil. We know we don't have the data of 10 megabytes or a few kbs. We got a lot of data, right? So even one day, a normal application, a mid-size application, can generate a 10 terabytes of data per day, right? So when we have that problem that nowadays there are a lot of data coming there from the application, how we can manage on servers, right? Let's say today I got 10 terabytes data of the application, and after a week it's going to be for 11, right? And after a year it's going to be multiplied by the time, right? So are you going to start maximize your servers? No, that's not a good solution. That's why people go into the clouds, because AWS and the cloud infrastructure are so helpful that we just have a pay to go strategy. We don't have any limitations of the scalability, as you know. Service, we don't have to manage our servers, and it's going to be scaled side by side. Also the high cost, right? So on premise is always a high cost, right? Just assume that we are in a company, and our data, the same example we can do for the data, we have 10 terabytes of data. So you can see we have to allocate a special floor, not a room, a special floor to maintain that data, right? We have to apply the air conditioners over there, we have to buy expensive servers over there, right? So, and we have to specifically arrange a team who can look into it, who can look the networks over there, the servers over there, right? So there are a lot of things. So that's the cut of the cost that our cloud can, can save. And also the complexity and time, everyone knows time is the money. And even so the things, when things are complex and we are going to solve, so it took a lot of time. The cloud is simple, we just have to do some training. People can train like 1 or 2 months if they have some experience in the tech. And if you are not that much familiar with the cloud, I promise you, you just need a good instructor, and it took only 3 months to be expert and just get the certifications done. Okay, so now let's talk about the what is ETL. So as you know, I have in the beginning of talk, I have told you about I'm a data engineer, right? So in the data engineer, there's a pipeline. There are pipelines. We are fetching data from a service, a API, or an application. We are going to transform it, and we are going to store in a place where our analyst, where our AI engineers, where our machine learning engineers are going to take that clean data and build some models over there, build some analytics over there, and create good things for the normal people, right? So this is what is ETL. ETL is basically a paradigm what we are going to use to make pipelines for our data, right? So it's a self-explanatory. E for extract, T for transform, L for load. So let me just give you a practical example how this is going to be done. Okay, let's say we have an application, right, which generates a lot of data, 2 GB data per day, right? So we are going to make solution on AWS or any cloud where we are going to extract that data with the application, right? After extracting that, we are going to transform it, right? Why transform? Because every business needs some different transformation. So let's say we are going to remove the duplicates, we are going to changing the naming convention example, and then we are going to load. Why we are going to load that thing? See, whenever we are going to talk about the load data, right? So nowadays there's a big data, a lot of coming here. So we really need a data warehouse or the centralized location where we can store a data with the history, right? So in the further communication, in the further slides, I'm going to introduce some services where you can look for, into the AWS, how you can load the data or ways you can load the data. Okay, so in the last step, the load thing is where people like AI engineers, machine learning engineers, and you can say a data scientist can took that data from and make a beautiful applications over there. Let's say ML models can their churn prediction, computer customer journey. This is all are going to be made after the ETL pipeline. Okay, so what are the AWS services for ETL, right? So as you know that all the big companies, all the big operations, there is a ETL over there. ETL is not is not an oh is no it's not a new technology, by the way. Extract, transformation, and load is a paradigm which is going to be used a lot of company back after like so many decades, right? But this is not that much highlight. All the AI things, all the machine learning engineers things has the ETL behind it. because everyone needs a clean data. They can't afford the messy data. That's why they need the clean data. So ETL is the thing that is behind it, right? So what places you can look for it? You can go for the Amazon S3. You can go, because everyone know this is an object storage, and this is really good for the raw and processed data. So this is a very cheap and good solution by the AWS, and I'm pretty familiar that everyone is, I'm pretty like confident that everyone is kind of heard about this thing. Then we have AWS Glue. So what is AWS Glue? AWS Glue is a processing engine where we can process our data, or you can say transform our data, because data is so big nowadays. So we need a serverless data integration service, right? So AWS Glue is a complete solution where we can make our ETL job. We can write code over there, we can write schema over there. So it's a great thing for the ETL link. And then we have again AWS Lambda, as Mattis already discussed Lambda a lot. So we can just write code over there. This is also a serverless, but the problem with Lambda is we can't put all the code over there, because Lambda is only run for 10 to 15 minutes, and it's not that much scalable options, because whenever we are going to talk about the data transformation, so it took a lot of time, right? Because the data is really big. So we need a thing like a glue. Then we have Amazon Redshift. I really want to spend my time in Amazon Redshift. So basically, there are two types of things to store the data. One is relational databases that we are most familiar in AWS. We can refer them as RDS, but in general, SSMS by Microsoft, and there are a lot of MariaDB, right? So there are relational database management system, but Amazon Redshift is a warehouse, right? So the warehouse is not like a same RDMS. It's have a different paradigm to store the data, and it is so efficient to store the data, right? So AWS and it is really useful for analysis of the data. Like we can create connections in warehousing in the Amazon Redshift, so people can fetch the data from there. Okay, then we have orchestration tool where we can automate all of the things, where we can link all of the services to make our job or ETL successful, which is AWS step function. Okay, so let's deep dive in like sample AWS ETL pipeline architecture. So I haven't made that. I'm going to repeat myself. Just go to my LinkedIn, and you can see the reference architecture over there, and you can just give an idea of it. So it's a very light talk. So I really want to give a very summarized way. So how we can make an ETL pipeline? Let's say we are getting data from an application, and we are storing that raw data on Amazon S3, right? Then we are going to use AWS Glue. So it's a clockwise, by the way. When we are going to use a glue, the glue is getting the data from the S3 and do the transformation. Like I said, removing the duplicates, like I said, removing the anomalies, removing the blank spaces, all of the stuff, changing naming convention, according all of the business needs, right? Then we are going to event driven processing, which is going to be Lambda. So Lambda is going to be used many ways. It's going to be trigger another service. It's going to be a clean your code a little bit. Then we are going to use Redshift, because Redshift is so important to store our data there, right? And to all this pipeline to orchestrate, we can use AWS term function. So folks, you really need like 4 to 5 service on AWS, so you can make your data pipeline. And I'm telling you, data pipeline are so important. Every mid to you can say a bigger companies really need a ETL pipeline, and the data is the new oil. So this is a really thing like I would love to do with the AWS, because it has a great services, and we can easily manage our data over there. Okay, so there's also a demo use case building a student data pipeline. So I really love to teach students, because I'm a student also. So there's a case study, a use case. Then you can use to it to just make a pipeline on AWS. So what you have to do again, you can just get the data from APIs and put that data into the S3 bucket. So you can say a weather API by the open API and stock prices, etc., etc. Then you can use Glue to clean that, and you can just put that data after cleaning into the Redshift, and you can visualize. again on the Amazon. So AWS has a complete ecosystem for you to make your data, right? So you can just take a snapshot of it, and maybe I can share this slide with you so you can create your data pipeline. And I'm telling you, just put this thing on your GitHub repository, make your repositories. So it's going to be amazing to show them that, hey, this is a problem that I've been solved. Okay. So one more thing, what are the benefits of AWS for all? Honestly, it's a cost efficient. Right now, things are going to a serverless way. So let's say if you have a lot of load, so you have to pay more, and if you have a very less load, so you got a very less, you have to pay very less amount of it. And also the scalability that I've already discussed, that scalability is a real problem that cloud has been solved. So this is what AWS actually solved that, and that's why AWS has a great market share, because AWS is working with the different government offices, so with the government government projects. So why government choosing AWS? This is why, because AWS is a trustable cloud, and it's an Asian, and it has a great market share. And also a career skill, gaining demand expertise of modern job market. A lot of job market, if you are talking about a web application, we are talking about the data side, AI, machine learning, data sciences, anything, DevOps, a lot of things has the services on AWS. AWS has around more than 200 plus services. So it has a let's explore and just deep dive into it. I just started my cloud learning after in my second year, in the initial start of my second year. Then I do apply some hands-on practice. The use case that I've been shared with you, this is exactly that I've made, right? And I just post on my LinkedIn. I just have a feedback from different industry expert, and this is a project I've been explaining into my interviews. Got an internship there, did an internship, and then I offer a full-time job. Then I'm currently remoting as a in an agriculture startup in my country, and which is I'm very proud of, and I'm handling all of the data in a province, right? And yes, that community matters, and I would love to thank you, Hiromi. So he just he did a great initiative, and he just sorry. So she did a great initiative, and she arrange all of the talks month by month, so we can just got connected from all over the world, and we have we have to things for the insight, and we can share our things, and we can support each other. Okay, so any questions so far you can ask in the chat. I would love over a day or two. I would love to help students or professionals who just begin their journey on the cloud. And yep, this is it. And yep, if anyone has a question, just please do let me know.
Hiromi.
Hi, thank you. Thank you, Adra, for your great talk. I really like the Cloud Girl program. It's such a wonderful initiative. As you said, AWS has many programs that support your users. I've also been supported by them, and had some great experiences. I'm really thankful for that. By the way, about data, I feel I now have more options on how to handle it depending on the project, and learning that the data lake can be used like a database was eye-opening. I know I still have much more to learn. That's all
Yeah.
from me. So, does anyone have a comment or a question for him? Okay.
Masino.
कोई नहीं easy.
Okay, right. Thank you so much.
Yeah, thank you everyone. Yeah, have a nice
Thank
day. Thank you.
Thank you.
Thank you. Okay, let's move on. Neam,
Hi, everyone. Let me
hello. Are you
let me
ready?
figure out how to share my screen and not lose everything that I want to be looking at. Okay. I might have to just opt for something a little weird. Um we are doing great on time, it appears. We are right on schedule.
Mm-hmm.
Mhm.
So I'm going to be sharing a bit about the Amazon culture and how it relates to interviewing. If you have ever considered applying for a job at Amazon as an intern or as a full-timer, you are probably familiar with the fact that we have a pretty unique interviewing culture. So that's what I will talk about. My name is Na Young, which is like Na old, but Na young. I identify as a Korean American. I live and work in Seattle, where Amazon is headquartered. Before then, I was living in a lot of places, but I guess I should move to my next slide to explain why I'm here sharing with you about my journey to Amazon. So, the previous presenter, Abdullah, is a current Cloud Club captain. That is the program that I work on at AWS, the Cloud Club program. But once upon a time, I also was a university student. And after my undergrad degree, I worked in consulting and a marketing specialist type of role. Went to graduate school because I realized that a lot of my evenings and weekends as a hobby was spent helping students find jobs for fun. I realized that I could do that as a career services advisor. So I got a master's degree in Philadelphia in the United States, and then decided that I wanted to take a risk, go on an adventure, pack my bags, and move to Singapore, where I had never visited, or Singapore, as the Singaporeans like to say. Worked at the biggest national university there for 3 years, and then moved back stateside to Seattle, where I have never lived, but I heard good things about. So I worked for the biggest university in Seattle doing career services program management work, and then started rethinking, is this really where I ought to be? Oh, and then I realized I didn't even turn on the video. My apologies. I think my video is on now, and hopefully it's showing my
Yeah,
face.
yeah.
Oh,
It's
hold on,
on
let me
your
see.
Cloud Club logo, but we can't see you.
Oh, how about now?
Yeah, we can see you. Yeah,
Okay,
you're
great.
looking great.
So I shifted to working at a SaaS startup that worked on technical interviewing with software engineering type of roles called Carrot. And then got contacted by a recruiter at Amazon who reached out to me on LinkedIn and asked if I wanted to come do that type of work, customer success management work at Amazon, Amazon.com, like the Amazon that you buy from. So that was my into Amazon 4 years ago. I started as a customer success manager, working with electronics vendors like Sony, Beats, LG, those kind of brands, and helping them sell strategically and effectively on Amazon.com. And then I started kind of itching for working with students again, because that's what, as you can see, most of my career has been. And then found out that there was a new team starting out in AWS developer experience, developing a student-centered, student-only community, which 3 years ago birthed into AWS Cloud Clubs. So I've been working on the AWS Cloud Club program as a program manager for 3 years now. So I literally reviewed every application from the first cohort until now. And right now we actually have our application cycle open for new Cloud Club captains until October 6th, 2025. So if you didn't know that, it's up online. I'll give the website at the end of my presentation if it's helpful. But that's me. So I want you to listen to the slides that are to come with this lens that I am not a recruiter, that I don't have a job that I could refer you to right now. But what I'm about to say is widely applicable globally, whether you're applying for a SA role or a business analyst role or a program management role. So, what are the Amazon LPs? You might have heard of one or more of these 16 leadership principles that Amazon has as part of our company DNA or company culture. The way that I like to think of it is these are our common language. These are the game rules when you play a board game together with a group of friends, right? Everyone who works at Amazon knows these because it's not just something that's written nicely on a wall in a building. These drive our decisions every day, right? So when it comes to like performance review season, right? Self assessments, writing feedback for colleagues, right? These are the things that we are asked to think and write because these are the things that matter most to us. I won't read every word on this page, but I can speak to a couple of them that have been top of mind for me. And one of them is earn trust. Right now, my team is in a growth stage where we have a lot of new teammates. It's really exciting. It's great energy. And it gives us more resources to do the things that we've been wanting to do. And earning trust, I believe, is one of the most important leadership principles to be successful at Amazon because you cannot achieve your goals and your desired outcomes alone. You need the help of many other teammates who either are in the same team as you or not. But I have found that some effective ways to earn trust are to listen before speaking, to ask good questions, to find commonalities, to build bridges across differences, especially because I work in a global team, right? I'm based in the United States, but a lot of my colleagues are not. So there's cultural differences, right, that are at play in addition to individual differences. And then inviting others to collaborate. And for me, I have found that to be more effective earlier than later. So earn trust is currently one of my favorite leadership principles. I'll also speak about frugality. I think this leadership principle is quite unique to AWS. I don't know of many other, companies of our size naming that as literally one of their most like important DNA principles. But it is unique, and I think oftentimes people think about like money or budget when it comes to frugality, which is certainly true. But in my personal view, um, there's kind of like three T's that one has at different points in life. There's time, there's treasures, and there's talents. And when I was earlier in my career or in university, right, I had a lot more time. I did not have a lot of treasures, and my talents were developing. Um, Currently, I don't have a lot of time, but I have a little more money. I have a little more budget. And then my talents have certainly developed and improved since I left university a couple decades ago. So I think frugality is, a leadership principle that makes you think about resources um, strategically. So you don't just go lavishly spend your money on like this and that without thought, but rather thinking through what would have the most reach, what would achieve my goals or my key performance indicators more effectively. And right now at this season, I've gone through some significant life changes last year. Like my family has grown in a couple numbers. So I'm thinking more about like what can I do to work smarter and not necessarily harder? What will have the greatest impact with the same or limited amount of choice that I make? So that's what I want to say about frugality. So I mentioned the 16 leadership principles, which I will bring back up here, and how I wanted to connect it with you all as just members of the community was how this applies to something like interviewing, right? So for me, I have applied for jobs in only 3 countries in the world, and most of you don't live in those countries. So I want you to listen to what I'm saying with that grain of salt, that your local, professionals or recruiters or career advisors at school, honestly, are probably going to give more relevant advice than I am. But this is relevant if you're interested in a job at Amazon. Okay. So if you're interested in a job at Amazon, you likely know, is quite public knowledge, that that the STAR method, which is a universal interviewing method, is a valued framework for interviewing, right? So for example, when I was contacted by my Amazon recruiter several years ago, they told me my interview schedule, and then they gave me a handout about the STAR framework as an attachment to the email. They said, this is the framework that your interviewers will be looking for. So, you should practice, right? Prepare using this framework, right? And if I was in the audience live right now, I would ask you all to raise your hand if you have heard of the STAR framework for interviewing. It is commonly used in the United States and Singapore, 2 places I have worked. I don't think it's commonly used in Korea, where I have worked as well. So if your geography doesn't use it, then ignore it. But at Amazon, this is very common. So you start with describing the situation that you were in, the task that you had at hand, what actions you took, and then finally the result. As someone who has been on many interviewing panels, I can tell you the part that most people do not do well is the last part, the R. A lot of people talk about STA and then they forgot to tell us the R. So we have to probe and ask them to elaborate on that. That is the most impactful part of this whole framework, the R, the result. So what I have found very helpful is writing it out. So here's an example of how you might answer a question about a time you had to make a decision which included short-term sacrifices for long-term goals, right? So the example is in italics. The most impactful part here is the results, the ending. With these actions, we're able to have consistent page load times under 3 seconds. I also share my experience with other project managers to prevent the situation from happening again. Results, when it can be quantified, are very impactful. So in this case, load times under 3 seconds. You could also do like time savings, percentage savings, like cost savings. Those are kind of quantitative metrics you could use. Non-quantitative metrics, also known as qualitative metrics, are also good. So being able to share your experience with teammates so it doesn't happen again, right? Like that, there's no number there, but it's very important, right? So as an example, how the STAR framework can be applied for an example question. And these are just some sample interview questions that are related to the leadership principles that I mentioned earlier, right? So the first question, this is a question that asks about the leadership principle of ownership, right? Or the second question, leadership principle about invent and simplify. So that's how I have seen in my own experience of interviewing at Amazon the leadership principles weaved into the way we hire talent, right? The way we interview talent. The internet is full of example interviews like this. So what I did when I was interviewing was I just got like a long list and then I wrote out STAR for each question because I wasn't sure what question I was going to get, right? For me, that exercise of reflecting on my significant experiences to date and then thinking about like what are the actions that I took and the results that came about were really helpful for me to feel more confident about the interview coming up. But yeah, that's sample interview questions. I will pause here to see if anyone has questions because that is the meat of what I had to say today. Typically, if I had a little more time and we were in person, I would say let's do a breakout for 10 minutes. Everyone pair off, pick a question, and actually write out your response right now and then practice verbalizing it to someone else and give feedback. That's what I would be having us do. But because our circumstances are not ideal for that, I will just pause here and see if any questions. If not, I can end a little early as well. I am not seeing anything in chat. And I don't think I hear anything, so perhaps there are no questions. So my last slide is our AWS Cloud Clubs, our student community. So this is like AWS user groups, but for college students, is now taking applications. And in previous cohorts, we may have been more selective than we plan to be for this one. We are in a growth stage right now where we want as many campuses around the world to have access to AWS and student-led community. So if you are a student or if you know of a college student in your user group or in your neighborhood or people that you've met here and there that you think would be suitable. October 6th is the deadline. Our application link is off of AWS Builder Center, which I think many of you are already familiar with. And if you or anyone that you know has questions, they could write to us at awscloudclubs@amazon.com. Or if you want to ask me directly, I'm on LinkedIn, Nayang Miller Wan. Happy to answer any questions offline as well. So thank you all so much for your time today.
Thank you. Thank you so much, Nirang. I really love your talk. Actually, when I first heard you in the Philippines, I was totally inspired. So your points on leadership principles are so valuable and something many people should know. My own work is in organizational development, focusing on both technology and people. What you shared about people really connects with me. At my company, we also have a principle of mutual management. Fits can only work if there is trust. So I ended up sharing a bit of my own story. So sorry. So now, does anyone have a question and comments or thoughts for her? Nothing?
So nothing.
Okay.
Okay.
All right then. Let's pass the mic to our next speaker. Hi, Jones.
Hey, Romy. Thank you for
Hi.
having me.
I'm ready.
Yeah, I'm ready. Just getting my screen up.
Okay, here you go.
Yeah, I guess my screen is also up now.
Okay.
Perfect.
Awesome. Thank you. So today we did have two speakers talk a little bit about Lambda and serverless. I'll be focusing more on the serverless part and how observability or monitoring is important with serverless when you're talking about Lambda functions, to be very specific. Before we get started, a little bit introduction about who I am. I'm Jones. I'm one of the AWS serverless heroes based out of India. I do co-run the AWS user group Bengaluru here in India. I talk a lot about serverless, be it with my blogs, newsletters, also co-run a podcast with another hero called The Zach Show Talking AWS. If you have uh, anything that you want to talk about with respect to cloud, AWS, or even serverless or observability, do hit me up on LinkedIn. I'm pretty much active there. So if you have any questions, you can shoot it my way there. I'm also a DevRel engineer at New Relic. Today, I'll be talking about a little bit of serverless paradigm, the observability challenge, and the pillars of observability when you're talking about Lambda functions. So you do, I assume that most of us today have heard the term serverless, and there are a lot of AWS services that are truly serverless in nature. When you talk about compute, Lambda functions definitely is the thing that stands out. But apart from Lambda functions, there are a ton of other AWS services that are serverless in nature, be it in terms of databases or be it in terms of application integrations or any of the other serverless capabilities with respect to building out CloudFront or even things such as Amplify. All of these come under the serverless wing of AWS offerings. We will focus primarily with Lambda functions because too many choices overwhelm. But when you're talking about Lambda functions, it comes to a fact that most of us are using Lambda functions in various parts of our architecture. It could be architectures that are hybrid in nature, where you could have something that's running on containers, Kubernetes, or even on-prem, and there's a section of it that uses Lambda functions because the core piece of event-driven architectures or things that is needs integration with other AWS services. So imagine if you had a complex and a very weird architecture, something like this, where you have systems in place, be it as events, either when the user uploads images or documents into S3, it triggers events via Event Bridge, triggering your Lambda functions, or even as simple as AppSync APIs or any of the front-end APIs using which is being invoking Lambda function, and that irrespectively triggers other AWS services, talks to DynamoDB, from DynamoDB, the streams triggering other Lambda functions as well. So in a nutshell, you do have a lot of triggers for your Lambda functions out there in a truly serverless ecosystem. Whenever these Lambda functions are triggered, you want to understand what are the sources, how is it performing. If there's an error, say for example, when we are using the same architecture and there was an error in one of the Lambda functions, you want to understand which was that Lambda function, where did this error occur, what was the whole hop in this error system, right? Because most of the times it's important for us to understand where and when, in which context the errors occur, or what was the error that is rippling under the errors, right? So it is important for us to focus on observability and monitoring when we talk about these matters. When, especially in the production, something goes wrong, you want to understand what is that something and where did it go wrong. When we talk about monitoring and the challenges that serverless brings in the space of monitoring is the fact that it is complex. Because if you remember just from my previous slide, there was a complex architecture. So this could be just a part of your architecture, or it could even be your whole architecture itself, where you have tons of other AWS services that are distributed over. It could be multitude of Lambda functions itself. It could be different kinds of compute services. It could be Kubernetes, it could be Lambda functions, or it could even be on-prem or other VMs that are running behind the scenes. What does it mean when you talk about observability? Because the very fact that these are the AWS services or HTTP calls invoking Lambda functions, you need to understand what is the whole trace. And these are not very easy, bringing in a lot of complexity for your architectures. Since there is complexity, there is also a lot of telemetry rush. When I say telemetry, it's the logs, metrics, and traces which is being sent from all of the other parts of your ecosystem or architecture. When these things go wrong, you need a better pictorial or a better holistic view about your complete traces, your complete flow of events, complete flow of invocations. So again, from the previous architecture diagram that I had, say for example, if the user uploads something into S3, S3 triggers an event bridge event. If that event in return triggers a Lambda function, and the Lambda function is making DynamoDB calls or other HTTP calls, you want to see the complete flow. And say, for example, in one of those HTTP calls, if something goes wrong, you want to understand why did it go wrong. It could be because you missed some of the input parameters, which is from the event. So you need to trace back the complete journey of that invocation. And to do that, you also need a lot of telemetry information. So getting all of this is a pain when you talk about serverless. And of course, compliance is something that's always on top of the minds for enterprises because you don't want every data to be logged. You don't want every kind of traces to be available, PII informations or certain business specific information to be logged. And it makes it hard for you to identify if it is truly based on certain parameters or attributes. It becomes hard for you to identify these errors. So since we're talking about Lambda functions, a little background about Lambda functions, it is ephemeral in nature. So when we talk about ephemeral, it means that whenever there's execution, the execution happens, the Lambda container behind the scenes are active, and after a while are destroyed. So when you want information about that specific container for that specific invocation, it means you have to dial down on specific logs and traces for those specific time groups, which makes it hard because the container could have been destroyed. And for you to understand these things, you have to enable monitoring at a very early stage because the data is lost once the container is destroyed. So having monitoring or sending in telemetry data either into CloudWatch, X-Ray, or a third-party observability tool, it is important to do it beforehand before something goes wrong. Since it's ephemeral in nature, the visibility is limited, and also the very fact about the infrastructure not being under your control. So you don't have control about the infrastructure, AWS manages for you, so you cannot ensure that you're having the containers running for specific periods of time. How do you get in the container informations? How do you get in the information about different kinds of runtime errors, different kinds of Lambda platform errors? So all of these are independent and you do not have control over them. Like I mentioned previously, Lambda functions or serverless in general is a very distributed architecture. So this comes with more complexity problems. All of that said, Lambda functions and cold starts are a thing. So you always encounter cold starts every now and then, and you have to be mindful about them. How do you identify these cold starts, and also how do you mitigate them? Be it with things such as snap start, or you may have to revive or optimize your codes. Whatever strategies that you have to address the cold starts. When we talk about these different factors or different challenges that Lambda function as an environment holds, all of these segments give you telemetry information. So either as logs, metrics, or traces, these are available. And what you do with these logs, metrics, and traces is that you send them into tools such as Amazon CloudWatch or AWS X-Ray, the native AWS observability tools. So these become more actionable telemetry data. So once you have them there, it becomes more easy for you as a developer to start querying on them, getting information about them, and looking at different X-ray traces, understanding what went wrong, where did it go wrong. But still, there are some challenges, yes, because most of the time, when you're working with CloudWatch or X-rays, the context switching is a problem. And although the data is there, it is fragmented and distributed like the serverless nature is. It is all over the place. So you may have to navigate across different log groups, different timestamps, start querying different insights from CloudWatch or with X-ray and start digging deep, which means as an engineer, you spend a lot of time digging into information because certain things are not available straightforward. This is where you start looking at other solutions, or be it in terms of OpenTelemetry or AWS distro for OpenTelemetry. That's another AWS open source project that is there, and also looking at other third-party tools like New Relic. What happens here is that these actionable telemetry information, the logs, metrics, traces, is being sent into one of these exporters, one of these destinations that gives you the complete picture about your traces or logs or metrics. So here's one such example where if it's a Lambda function that you're using, and you would be using something called as Lambda layers. So be it in OpenTelemetry, AWS distro for OpenTelemetry, or something like New Relic, or any of the other AWS vendors for observability, you get to choose their Lambda layers, which has Lambda extensions. So you use those ARNs, add them into your Lambda functions, and configure your environment variables. So whenever this is done, the Lambda environment, whenever the executions are being done, they will send in the telemetry data to the respective configured destinations. Now, how do you do that? For somebody who's using CDK, this is one such example, a snippet of code where you're creating your Lambda function. Along with it, you're adding certain things such as your Lambda function layer on, and also your credentials for your New Relic account, but this could also be any of the other vendors out there or OpenTelemetry, whatnot. You configure your Lambda function environment variables with the needed things that you want, be it in terms of enabling or disabling logs, metrics, or traces, or even in terms of telling in the level of your logs that you need, all configured right from your environment variables, and enabling traces so that you get the traces from Lambda function. Once that is done, deployed in production, what could go wrong, right? Like, you have this up, and today is Friday evening for me. So probably if I'm one of the SREs or somebody on call, I would be chilling on my Friday evening, but in production, anything could go wrong at any given point in time, and probably I'll start getting some alerts if something goes wrong. If something goes wrong, so many alerts means that I have to figure out what went wrong. So you start searching at what are the things that are going wrong, what are the Lambda functions, what are the different services, what are the different microservices, what parts of my architecture have been affected. So what do is start triaging. You start looking at alerts, you start understanding, okay, this is an alert from ABC Lambda function, and this is an alert from XYZ Lambda function. So understanding which is the starting point is crucial from your Lambda alerts configuration. Now, since you already understand that at this point you're getting alerts, and how do you triage is basically start using the pillars of observability. In pillars of observability, in context of Lambda functions, you may have logs, which you start logging in, be it in terms of your programming languages that you choose. You start adding in things like print or console logs, having them at different stages, especially when something goes wrong in your error retries, in your error catch scenarios, and also making certain logs available so that you know for a fact that when an execution happens, you know the flow of execution in your code, and the logs replicate the same. At the same time, you do not log everything, because logs also come with a data ingestion cost and data storage cost. Here's one such example with logs where you get information about error and missing user ID with Along with logs, you add in certain other attributes and metadata, making it more enriched so that you know for a fact which Lambda function this is in, which is the specific flow in which the error occurred or the log is from, so that when you're looking at your source code, you know as a developer, this is the exact line this log is from. The other pillar that is there is metrics. Metrics are nothing but aggregated data for your telemetry information. So it could be things such as giving you information about the duration of your Lambda function invocations, the number of retries, the number of invocations, the error rates that are there, the number of triggers, also the fact about when you're talking about Lambda function, the number of cold starts, the number of concurrencies, so that you know holistically at a given time span how is your Lambda function performing, be it in terms of understanding the throttling or performance, or even in terms of identifying cost factors for your Lambda functions. The other is one such important pillar is the traces, because when you're trying to triage, when you're trying to figure out or debug some of the errors that are happening in Lambda functions, you need to understand what is a trace. And what is a trace is that it's basically the complete information about your invocation journey. So say, for example, you have an API gateway triggering Lambda functions, and Lambda function is making calls into your DynamoDB table. So you need to understand what are the different hops this Lambda function is taking from your API gateway to your Lambda function execution to your database call and the back as well. Most of the times, I know one of the speakers today earlier mentioned about strands and using Bedrock agents, all of them. So when you're using something like that in context of Lambda functions, you need to understand the different hops these have, especially when you are working with LLMs or other Bedrock models. You need to understand different parts of latencies these bring in, the number of time that these executions happen. So all of those informations are available in your trace. So trace gives you the complete hops your Lambda function or your environment does when it's being executed. Especially when something goes wrong, hops gives you an information telling that, okay, at this specific span, this specific error happened, and this caused rippling effect back into the service that was invoking. Here's one such example where if something goes wrong and you want to look at different errors out there, what New Relic does is classifies all types of errors and gives you information about those errors, and giving you the error messages, collating all of the logs that these error messages were occurred with, and the complete information about the timestamp, the error class, so that you can understand, okay, this was the error, and these are the logs that caused these errors. So as a developer, you know this error and the logs that this error was caused with, making triaging and identifying errors more faster and easier so that you can fix them faster. Now, with that all said, you're introducing Lambda layers, you're adding in configurations, and all of those. Something that you would have to be mindful of when especially adding observability tools into your Lambda functions is that Lambda function can get heavy because these Lambda layers could be heavy, especially if you're using something like OpenTelemetry. They are huge Lambda layers, and you could start running into Lambda layers limits, and also in terms of having other layers under the hood for your Lambda functions could cause you certain performance overheads. Because you have the number of Lambda layers, you also start encountering more frequent cold starts or longer cold starts. So this hits a toll on your performance, but these are some trade-offs that you could do because observability matters more than having certain trade-offs. One such important thing is configuring the right environment variables. So say, for example, if you're disabling logs and trying to understand, I don't see logs in my observability tool, it becomes hard because your configuration on your Lambda function environment variable says logs are disabled. So you may have to look at the right logs, like configurations that you want to look at for your observability solution. All that said, what are the next steps? because having your observability is one, but also ensuring they're enriched is the other step. So when you're logging, ensure that you do add in certain metadata attributes so that it's easier for you to identify where to triage and understand what went wrong at which specific spot. When you're using metrics, it's important that each person in your organization will be looking at different metrics for understanding the health and the performance of your Lambda function or your entire application stack. So having different data-rich dashboards specific to different roles is more important. So say, for example, I'm a developer, I'm more interested in the number of errors, the number of code starts, but there's another architect in the team who is more interested in the cold starts, the concurrencies, the number of error retries, or the timeouts. So, as a person who's bringing in different business values, you may have to have multiple dashboards that are set in with the right metrics needed for the right business. Like I was talking about errors and alerts earlier, whenever there's alerts, you need to have the right context, the right information for your alerts so that you can understand where is the starting point for triaging and identifying these errors. Most importantly, alerts could also have deep links and information for your exact errors, making triaging more smoother and easier for you as developers to identify where something went wrong. I'll take a pause here to see if there's any questions or anything such in the chat. Or if you want to connect with me, the QR code is still available. So in case if you have any questions outside of this talk or on AWS or serverless, feel free to reach out to me on LinkedIn. So thank you all.
Hi, thank you. Thank you so much, Jones, for your great sharing. Oh, Lambda function really are hard workers, and we don't want to regard them without a problem. It's also important to make sure there aren't hidden root issues. With so many options out there, we need to understand its future, design carefully, and make strategic choices with observability in mind. And of course, not just monitoring, but moving toward AI apps too, right? Okay. Yep. This talk really reminded me of that. Thanks again for sharing such an important message. Thank you. Again, does anyone have comments or question for Jones? Okay. Right. Thank you
Thank you,
so much.
Ravi. Thank you.
Thank you. Okay, let's welcome our final speaker today. Hi, Demo. Are you ready?
Hi, everyone. Okay.
Hi.
So I'm going to start sharing my screen. Just let me know.
Mm-hmm.
Okay. Is my screen visible?
Great.
Great. Okay. So my name is Domalai. I'll be giving a talk on Apache Finras migration pathways with AWS. So this is a bit technical, but I'll try my best not to make it so technical to cater for the different audience type we have today. Okay, so a little bit about me. I already mentioned my name is Malai. So I have attached the QR code to my LinkedIn. You can scan it if you want to connect and reach out later. I'm a cloud engineer at a leading fintech company here in Ghana. I'm 3 times AWS certified. I'm the first Ghanaian female AWS community builder. I actually say first, but currently I'm the only one, which is very sad and unfortunate. But I am on the goal of helping or including more Ghanaian females into the AWS community builder because it's an amazing community. I'm also the co-lead for the AWS Accra user group here in Ghana, and I have an NGO of my own called Your Choice in Engineering Matters. So just on the slide is pictures of my NGO work, and pictures of me at re-events 2024, where I actually met Hiromi. Okay, so I have categorized this presentation into three main parts. So first, we are going to look at what Apache FinRax actually is, just to give a brief overview for everyone here. We are going to look at the AWS setup for the Apache FinRax. So we look at the actual setup and then the DMS migration part. And then we will highlight briefly on additional configurations you could add if you want to try it at your end. Okay, so what is Apache FinRax? So when you hear Apache FinRax, what I want you to think about is it's simply your banking system, your traditional banking system that has been turned into an open source software tool. So you could think of transactions that are made by different clients that bank with the particular bank, let's say Bank A. So you could think of like transaction histories they've had in the month. You could think about like their savings summaries, anything that has to do with the company that is banking with Bank A. So that has been collectively put into a software known as Apache FinRax. That is an open source you could easily use to spin up your own version of it at your site. So why are we migrating Apache FinRax? Because remember from the title, it was Apache FinRax Migration Pathways. So today I'll be talking about migrating from Apache FinRax 1.7 to Apache FinRax 1.10 using some AWS services. So there are several reasons why we need to migrate from 1.7 to 1.10, but I'll just touch on the main reasons. So the main reasons is 1.7 is becoming obsolete. It actually only supports MySQL database, that's the versions 5.6 and 5.7. And if you're using AWS as your database, you would have to pay extra for end of life support, which I mean, we are all trying to be frugal in terms of money we spend on AWS. And so the new FinRax 1.10 supports recent versions of MariaDB. So we're actually moving away from MySQL and the constraints of the older version to MariaDB and the newer versions. So we will also be looking at newer versions of the applications which will provide like better security, better performance, even though there'll be like differences in schema names, but then better monitoring and observability. All right, so FINRAC terms. So I'll probably be mentioning a few jargons, not so much so that everybody here has like an understanding of what's going on. But then I want you to keep these four main FINRAC terms in mind because they would be showing up in the presentation. So first of all is MIFOS or MIFOS, it's a noun, so however you want to pronounce it. But when I mention MIFOS, I want you to think of basically it's just the front end together with the back end of Apache FinRax. So I said Apache FinRax as an accounting software open source tool. So if you think of the front end and the back end collectively, you get the term MIFOS. And in simple terms, you can think of it as a comprehensive dashboard that allows you to interact with the Apache FinRax tool. So I would also mention Tomcat. So Tomcat is actually the Java application. So Apache FinRax runs on a Java application. So I want you to think of Tomcat as the container, or the server that allows you to run the Apache FinRax and be able to access it on your web browser. So like I mentioned earlier, we're migrating from 1.7 to 1.10. So that means we are also migrating away from the Java application Tomcat 7 to the newer Java application Tomcat 10. Right. So now there are two main databases that always show up when FINRAC is being discussed. So that's FINRAC defaults and then FINRAC tenants. So depending on the version you are on, it would either be FINRAC default or MIFOS tenant default. So they're just the same database, same purpose, but just different names because of different versions. And FINRAC tenants, MIFOS platform tenants. So just similar to that, it's just the same database, same purpose, just different versions. So the Tomcat 7 which is the one we are migrating away from, uses Mifos tenant defaults and the Mifos platform tenants. And the new one we are migrating to uses the FINRAC defaults and the FINRAC tenants. I know it could be a lot, but then just to make it simple, let's just keep the one we are migrating to. So that's a Tomcat 10. So that will be FINRAC defaults and then FINRAC tenants. So the database FINRAC defaults simply, it holds the actual business data of the tenants. So when I say tenants, I'm referring to maybe the clients you are supporting or providing financial services with Apache FINRAC. So it could be, let's say, company A, it could be microfinance, HNL. It could be any company that has come to you for financial services with your Apache FINRAC software. So FINRAC default holds data such as the different clients of you have, the savings summary, the transaction history that have been going on with the individual tenants that I mentioned, that like companies or banks that you are supporting. Now, FINRA tenants is actually, so here's actually the list of tenants you are supporting, plus their metadata, so connection details, in any configuration details about these tenants are the ones stored in FINRA tenants. So there's no actual data that is stored for customer data in FINRA tenants, but just the actual connection details of the tenants. Okay, so quickly, so this is just a simple AWS setup we have here. So we have the EC2. So you can actually spin up Apache FINRAX in containers or EC2, but for this purpose, we are using EC2. So I have attached a snippet of my Terraform configs of the EC2 and the RDS. And one key thing to note for Tomcat 10 is you need an elastic IP because that's what you would use to access the UI in your browser. And you wouldn't want the IP to be changing every time you want to access the UI. So these are the next slide is 2 key configurations that you need to keep in mind when it comes to Apache FINRAX. So that's the configuration for the env.js and the configuration for the setenv.sh. So nothing really scary here. All you have to know is that the env.js is where you would update with your elastic IP I just mentioned to reflect when you're trying to log into the Apache FINRAX UI. And then for the set env, this is sort of the integration between the RDS you spun up and then the FINRAX application. So this allows FINRAX to know that the database you are interacting with is with this particular RDS host with a particular port and then the particular username. And you can see here the FINRAC tenants I was mentioning about. So this is just a sample screenshot. It could be more configs, but this is just a sample screenshot of you integrating the Apache FINRAC to talk to your database and updating it to have your elastic IP. All right. So once you've set up your EC2, you set up your RDS, you've done the necessary config updates. Remember, we are migrating from the older version Tomcat 10 to the newer version Tomcat 7 to the newer version Tomcat 10. So we would have to do a DMS migration. Another key thing to note to remember is for the older version, we were using MySQL, but now we are migrating to MariaDB. So that means there has to be a schema change. So first, after setting up all your AWS infra, your config for Apache FINRAC, you need to start the Java application. When you start that Java application, it allows FINRAC to run its migrations and create the necessary tables it needs. So that's very important to do before you actually start the DMS migration. So with the DMS migration, you have to create your source database endpoint, which is the MySQL database. And then you have to create your target database endpoint, which is the MariaDB FINRAX database. Now you have to create your replication tags to replicate the data from the MySQL to the Maria. So note over here, I attached the table mappings here, and I want us to look carefully at the second rule. So that's a transformation rule. And we're transforming the schema name from Mifos tenant defaults I mentioned earlier to the newer version name, which is FINRAC defaults. And there are other rules, which is just a short snippet of the other tables we replicating data from to the newer version. So then you just start your replication. You could choose to use a replication instance, or you could use DMS serverless. Anyone works to migrate your data from Tomcat 7 to Tomcat 10. All right, so attached here to our Finrat UI screenshots. So on the left, we have is the newer version of the Tomcat. So this is MIFOS for Apache Finrat 1.10. And then this is the login version of the older version, Tomcat 7. Now, a key thing to highlight here, just to give us a pictorial view of what goes on the application. So we can see the list of clients here. So when you log into the UI, you have the options to view a lot of things. You can see all the list of the names of the clients you have, the client IDs that are there. You can see the particular office those clients were assigned to and the particular staff. Now, this is just one particular page, but you could also have a saving summary page where you can see the list or the summary of savings the company has done in a month. You could also tweak it to see the summary of transactions that has done in a year or 3 months. And this is very good for reconciliation and having insight into the amount of money or the amount of the trend in transactions for your clients. All right, additional configurations. So we all know how important monitoring observability is in terms of seeing how your application is performing. So an additional config you could add to your setup is installing OpenTelemetry connector or the hotel connector. So with that, you would have to update the setenv.sh we looked at earlier with the details of your hotel connector. And from my example, I usually do that for APM monitoring on Datadog, application performance monitoring on Datadog, which is very key to have insights into latency, CPU or errors or memory performance. And talking about scalability, you could look at the option of having a multi-tenant system where you would have multiple tenants. So we looked at what tenants are. So tenants are like individual institutions. So you could have like individual institutions on a single Finrat tenant. So this also allows a horizontal sort of scaling. And so that brings me to the end of my presentation. So a brief summary, we looked at what Apache Finract was. We said it was an open source software, banking software tool. We looked at the different terms like MIFOs, Finract tenants, Finract defaults. We looked at how to set that up on AWS, and we looked at how to use DMS to migrate it from Tomcat 7 to Tomcat 10. I hope it was not filled with jargons and we at least got an overview of what the presentation was about if you are not from a fintech background. But if you have any questions, feel free to ask or we can connect on LinkedIn. Let me put this back here. We can connect on LinkedIn and continue discussion from there. Thank you.
Thank you, Thelma. Thank you so much. I'm so happy to see you again, and I really hope I can visit Ghana someday. Thank you
Yeah,
for
yeah.
I hope. So thank you for the very interesting talk about Finalect. Honestly, yes, sorry. Honestly, it was my first time hearing about it. So I really appreciate you introducing it. I definitely look into it more myself. It's always you. Sorry, it's always great to learn about areas I don't usually use. The Finalect UI also looked very clear and gave me a sense of a good experience. Thank you so much. Again, does anyone have any question, comments for her?
No questions and no comments.
Okay.
Mm-hmm.
Okay, thanks. Thank you so much. Thank
Thank
you.
you.
Thank you. With that, we've come to the end of all the talks today. Let's move to the closing. Thank you so much for staying with us until the end. Okay. So 2 hours went by so quickly. Okay, before we finish, I want to say a big thank you to all of you speakers today. Thank you so much. Each of you shared and great and inspiring ideas, and we all learned a lot from you. We really appreciate the time you spend with us. Before we close, please feel free to share your social links in the chat so we can stay connected. And if you enjoyed today, please tell your AWS friends and this community. We'd love to welcome them too. So thank you again, everyone. It was wonderful meetup, and I hope to see you at the next time. Bye for now. Thank you so much.
Thank you so much. Bye.
Thank you so much. Bye.
Bye.
Bye. Thank you.
So, bye.